Everyone's doing great. Today we're going to talk about the Pythagorean Theorem. The essential question is how can I find the missing side of a right triangle? And the learning target is I can use the Pythagorean Theorem to find the missing side lengths in right triangles. I'm hoping by the time you guys are done with this little mini lesson and your problem of the week, you'll have a better understanding of how it works. Let's go through some quick vocab. So vocab, first term we need to know is hypotenuse, the side opposite of the right angle in a right triangle. So you'll notice that it is always going to be away from the right angle. It's not connected to it at all. The next term you're going to need to know is legs. Those are what are connected to the right angle. So the two sides that form a right angle and a right triangle, these connect to the right angle. They actually form the right angle. You'll notice that the legs are called A and B, and the hypotenuse is called C. So it doesn't matter if I call this leg B or this leg A, but it's important that we always are consistent with calling the hypotenuse C. It will make a little more sense in a second. Finally, theorem is a relationship in mathematics that has been proved. Okay, the Pythagorean theorem is in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. You can summarize that to be a squared plus b squared equals c squared. If we look at the model of the triangle here, you'll notice that a and b are the legs, and C is the hypotenuse. You should also notice that C, the hypotenuse, is always going to be the longest side of a right triangle, whereas A and B are always going to be the legs. Okay, so we can prove that the Pythagorean theorem works by using one of the most common Pythagorean, let me restate that, right triangles, and that's a 3, 4, 5. A 3, 4, 5 right triangle is actually considered to be a Pythagorean triple. We'll get into that later. So in this particular right triangle, we know that the left side of the right triangle is 3 units, the bottom is 4 units, and the hypotenuse is 5 units. So if that's true, based on what we know about the Pythagorean theorem, I'm going to go ahead and turn on my pen real quick here. Based on what we know about the Pythagorean theorem, we know that a squared plus b squared should equal c squared. So let's go ahead and replace a, b, and c with some numbers. We know that a is 3 squared. We know that b is going to be 4, so we're going to go ahead and square that. And we know that c, or the hypotenuse, is 5 squared. So if this were to work, the sum of these two squares should equal 5 squared. So when we're finding the area of a square, it's really easy. You just take this side length and you multiply it by itself. So we know that 3 times 3 is indeed 9. So the area of that square is 9 units. We also know that 4 times 4 is 16. Finally, we know that 5 times 5 is 25. So we know that 3 squared is 9. We know that 4 squared is 16. And we know that 5 squared is 25. Now, conveniently, the sum of 9 and 16 is 25. So 25 equals 25, which is what we expect. We expect the sum of the squares of the legs to equal the square of the hypotenuse. So that's a really simple explanation of why it works. All right, let's move on to our first real example. So use the length, find the length of the hypotenuse in a right triangle with leg lengths of 9 and 12 units. When you're setting up a problem like this, the first thing you need to do is sketch a right triangle. So I'm going to go ahead and do that. Don't worry about it being scaled. Don't worry about it being perfect. Mine's definitely not going to be. So I'm going to go ahead and sketch something that looks like a triangle. Doesn't have to be perfect. I'm going to go ahead and say my right angle is here, which means that this side over here is my hypotenuse. We're trying to figure that out. I'm going to go ahead and call that C. I'll put my 9 here and my 12 there. So remember, when you're setting this up, you want to have your one leg squared plus a second leg squared. You want that to equal your hypotenuse squared. So our first leg is 9. Our second leg is 12. And our third leg, sorry, I forgot the square there, is c squared. Okay, so let's go ahead and simplify this. So 9 squared is 81. 12 squared is 144. Okay, 81 plus 144 is 225. So I have 225 equals c squared. Okay, now, right before we left for the quarantine, we were going over how to find the square root of values, or how to get rid of a squared value. We do that by finding this square root. So I'm going to go ahead and take the square root of both sides. Now, 225 is actually a perfect square. It's actually 15. So the square root of 225 is 15. So 15 equals c. We usually flip that around to be c equals 15. If you don't know that, that's fine. If you don't know that the square root of 225 is 15, if you don't have that memorized, that's perfectly fine. And the reality is most of these questions aren't going to have an integer as an answer. So let me show you a tool that you guys all have access to if you have internet access, and that's called Desmos Calculator. So I'm going to pop it up real quick. We did put a link into the Google Classroom so you can find it. If you want to graph, you can hit the start graphing thing. It's really great for that. But what we need right now is just a simple scientific calculator. So if you left yours at school, your phone's kind of weird, you can go ahead and use this. That works pretty good. So click on the scientific button, and we want to find the square root of 225. So I'm going to hit the radical sign. Remember, the radical is what we call the square root sign. And I'm going to enter 225 underneath that. And conveniently, as you can see right here, it will go ahead and give you that answer. You're going to want to use this tool or a different calculator to make sure you're getting these answers correct. I do not expect you guys to have all the perfect squares memorized up past 12. And furthermore, most of these are going to result in decimal anyway. So just keep that in mind. It's a great tool. I recommend you use it. Okay, let's look at another example. Okay, example 2. A baseball diamond is a square. Convenient. Baseball regulations require that the bases have 90 feet between them. What is the shortest distance between home plate and second base to the nearest foot? So we have a triangle set up for us already. So really what we're trying to do, we're trying to figure out C, right? Because it's a square. As you round first base and go to second, you're really making a kind of elongated 90-degree angle. So you're going to run here, then you're going to run there. So the question is, how far are we from home plate to second base? So we're going to set that up. And we're going to go 90 squared plus 90 squared equals c squared. Now you might want to use a calculator for 90 squared, but you know what 9 times 9 is. 9 times 9 is 81. So since you're adding a 0 to each one of those 9s, you just add 2 zeros to that. And 90 squared plus 90 squared is 8,100. And then we have another 8,100. All right, then you have equals c squared. Find the sum of these values. 16,200 equals c squared. Okay, now I'm going to be honest with you guys. I do not know the square root of 16,200. I'm not going to lie to you. So I'm going to go over to my Desmos calculator. I'm going to click on that real quick, switch screens. I'm going to do the same thing again, but I'm going to put in there 16,200. Okay, based on that information, it looks like the square root is 127 and 2800ths or thereabouts. So I'm going to round that to 127 and 3/10. I'm going to go ahead and use that as my answer. So my answer down here would be 127 and 3/10 equals c. Since we know that this is in feet, I can say I have 127 and 3/10 feet. That would be my answer. That's the distance between home plate and second base. Okay, one more example here. This last one is a little bit different because in the first two, we were finding the hypotenuse. The hypotenuse being the missing side. The missing side would be opposite the right angle. This time we're going to find a missing leg. So you notice that we have a leg and we have the hypotenuse. But we don't have this leg. So let's go ahead and identify what we want to call that leg. For the sake of, let's just call it B. It doesn't really matter what we call it. I'm going to go ahead and write a B right here. Okay, let's go ahead and set up an equation. So this time it's going to be 12 squared plus we're not going to put a number here. We're going to put B. B squared and then equals 14 squared. Okay. So you notice this time we're not finding the hypotenuse. We already know it. We're using the hypotenuse and one of the legs to find the missing leg over here. So 12 squared is 144. We don't know what b squared is yet. That's fine. 14 squared is 196. So now, just like you're solving any equation, you want to isolate the variable by moving the constant away from it. So I'm going to subtract 144 from both sides. Okay. That will leave us with b squared equals 52. Okay. So I know that the square root of 52 is going to be slightly greater than 7 because the square root of 49 is 7. I don't know the exact number, so once again I'm going to go ahead and switch over to Desmos. I'm going to click on this, and then I'm going to find out what the square root of 52 is. So the square root of 52 is approximately 7 2/10. So I'm going to go ahead and say that's my answer. So let me go back to my PowerPoint here. So we can say B. I can find my cursor. My pen's not wanting to work for me right now. There it is. B is approximately 7.2 units. All right. Okay, so that is the basics of the Pythagorean Theorem. I hope you find this helpful. And if you guys have any questions, feel free to email myself or Miss Olson. Have a